So hello everyone, I'm Aghiles Begriche from the University of Sherbrooke. I'm a PhD candidate. It's a great pleasure and an honor to be with you today, unfortunately in virtual, not in presential, but I'll try to share with you through my presentation some traps and recommendations from my experiences and observations during my laboratory works on UHPCs under the supervision of Professor Areski Tagnitamu and Professor Amariaya. So we are going to begin with a short introduction. After that, we will see the different traps, the effect of the water versus superplasticizer, water to binder ratio versus the superplasticizer content, the importance of time for the slump flow test measurement, the mini-cone slump flow manipulation, the importance of the cubic sample preparation, and we'll finish with a short conclusion. After the consultation of many references in the literature concerning the fresh tests on UHPCs, and after many manipulations and laboratory tests on these materials, I observed some mistakes and traps during fresh tests, some details that can easily influence results and waste time. So I will share 4 points. I selected them considering that they can be traps during fresh laboratory tests. For the first trap, it's not really a trap, but an observation related with the second one. So there I present the mixed design of two mixtures, one with 0.20 water to binder ratio and a superplasticizer saturation dosage of 2.3%. The second with 0.25 water to binder ratio and a superplasticizer saturation dosage of 1%. We can note that we need an additional 1.3% more of SP by mass of cement to achieve the saturation dosage. So we increase it more than 100% to decrease the water content by only 42 liters. With this observation, let's see the second traps, the importance of the slump measurement time. As we can see there, I present the evolution of the spread flow diameters at 3 different times, at 10, 30, and 50 minutes after the end of the mixing protocol for the precedent 2 mixtures. And we can easily observe that the maximum slump flow is achieved only after 50 minutes for the first mixture, in opposition to the second one, where the slump flow is generally stable during all 50 minutes of the age. So it's very important to consider the measurement time seriously for an optimization of the mix design and a comparison between mixtures behavior. Otherwise, we can easily have surprises and impact the study. It's also important to note that the variation of the superplasticizer from 2.3% to 1% by mass of cement with an increase of only 42 liters of water gives higher and more stable spread diameters in function of time. As you can see also there as a confirmation with the flow curves for the same mixtures, for low water to binder ratio mixture on the left, the slope decreased during time, reflecting a visible decrease of the viscosities. So an improvement of the rheology, comparing with the same mixture with a higher water to binder ratio, where the rheology is globally the same during time, almost stable for all the 50 minutes. Concerning the slump flow test manipulation, normal standard test must be conducted as it's presented in the top of the figure, and not like in the second part of the picture. The factor which can impact the quality of the test is the time we can take between the filling of the mini cone molds and its bring up. So for UHPC's concretes, if you take more than, let's say, around 1 minute approximately, it depends of the quantity of water, the superficial tension between the internal cone surface and the studied material increase fastly regarding to the low water content in the material, even if you correctly wet the cone. What can induce a displacement of the material with the cone? So the fall of the material certainly influences the results, in addition to the part of the material which can stick to the internal surface of the cone. So it's very important to lift the cone without any delay during our tests. Concerning the preparation of the cubic samples for compressive strength tests, the behavior of the material during casting in the molds induces air trapping, as we can see in the video. And regarding to the high viscosity of this kind of materials, in addition to the quick formation of very thin crust on the surface of the sample, certainly due to the low water content and its evaporation at the contact of the atmosphere after application of vibration, as we usually do, the entrapped air bubbles goes up and stay entrapped under the surface. It's not really visible during the preparation, but we observed it during the compressive tests. As you can see, it's easily observed in the pictures. So the cube is still strong, seems to be strong, but the failure of this layer, of the entrapped air layer, stopped the test and certainly gives lower resistances at the end. As an example, this graphic results present the comparison between two mixtures of 0.20 and 0.25 water to binder ratio, and 0.25 shows higher strength both at 7 and 28 days compared to the 0.20 mixture results. The entrapped air may explain that, as we didn't observe that kind of entrapped air layer on the top of the samples with the 0.25 ratio mixtures, being these mixtures less viscous than the lower water content mixtures. So we recommend to break the thin crust at the top of the sample during the vibration to eliminate at the maximum the excess of the entrapped air during the molding of the sample. So as a conclusion, we can say that UHPC is a wonderful concrete for all of us there, if well designed and tested. In UHPC, the water to binder and the superplasticizer effects are not at all linear. The rheological test should be done considering time as a principal factor. The entrapped air content can be higher at lower water to binder ratio after casting, which can affect strongly the compressive strength of the cubes, especially during a comparison between different mixtures. I think that a better guidance should be developed for UHPC testing at the fresh state because of its complex fresh behavior and sensible behavior during this phase of this material. So thank you very much for your attention.